Welcome to another episode of the .NET Show. In this episode, we're going to talk about ADO.NET. ADO being a great way to write applications that utilize databases, and .NET, of course, being a great framework by which such applications can be developed in. So we're going to talk about the architecture as well as some of the programming aspects about ADO.NET in this episode. But before we get to that, I'd like to take and let you know a little secret, is if you're going to attend the October PDC down in Los Angeles, which is going to be October 22nd through the 26th, you'll be able to meet both Erica and myself. We're going to be down there filming an episode of the .NET Show with a live studio audience, so you can actually get a chance to sit in and ask questions of some of the people we're going to be talking with. We'll also be doing an architectural panel, some news, and various other film footage that you get a chance to see if you're an attendee of the October PDC. So be sure to check out msdn.microsoft.com/events/PDC for information about how you can register to be part of the attendees of PDC. Now let's go check in with Erica and the news.
Hello, I'm Erica Wiechers. Welcome to the MSDN News Update. In early August, to aid programmers and designers to adapt their applications to the new Windows XP visuals, the Windows XP design team prepared some documentation and guidelines that carefully illustrate the way standard Windows elements, icons, and layouts are presented in Windows XP. This collection of style elements and controls provides a base of design specifications and implementation details for anyone developing applications for Windows XP. Also in August, Microsoft made available a Beta 2 Emulation Edition preview of the next version of the Windows CE operating system, currently codenamed Talisker. The downloadable emulator will aid developers in getting their applications prepared for Talisker. Developers will find a broad range of new and enhanced features, including wireless technologies, device emulation, a platform wizard, and rich multimedia and browsing capabilities. The MSDN Academic Alliance provides a simple and cost-effective way for academic departments to obtain a subscription to the full suite of Microsoft development tools and platforms. Similar to a normal MSDN subscription, its members get regular mailings of CDs that include all of the software, documentation, sample code, and updates that will allow them to stay current with all the latest technology tools for instructional and research use at a very low cost. The MSDN Academic website at www.msdnaa.net provides information that is specifically targeted at the academic community. In August, Microsoft made available the Experience Visual Studio.NET Hands-On Labs. Originally used at TechEd 2001, the labs exposed developers to the programming features within Visual Studio.NET, including an introduction to C#, ASP.NET, and Visual Basic.NET. The labs can be viewed individually online or downloaded as an entire set from MSDN. And as usual, you can find links to more information about these news items in the transcript. That's been the MSDN News Update. I'm Erica Wiechers.
Welcome back. Like I said, today we're going to talk about ADO.NET, helping us understand the issues regarding the new database model for .NET, as well as how existing applications using ADO can think about taking advantage of some of the capabilities added to it. To help us understand the issues of ADO.NET, I've got Michael Piazzo and Sean Draine with us. Sean's a program manager and Michael's a software architect. Thanks for joining us.
Sure, thank you.
So ADO.NET. I assume that it's more than just taking ADO and adding the .NET extension to it.
Yeah, it's much more than another three-letter acronym, I think. With ADO.NET, we basically, kind of from the ground up, rewrote the data model, taking what we liked from ADO, taking some of the good stuff from there, and then designing it in a way that basically has internet applications in mind and scalability in mind, so that basically the data model promotes building scalable network applications.
Yeah, a lot of what was in ADO was really carried over from previous technologies like RDO and DAO, which went back to Microsoft Access's database model, and it was largely designed around two-tier client-server models. And what we did in designing ADO.NET is we talked to a lot of customers in a very different world of three-tier architectures. The internet has changed a great deal. New technologies like XML have come into play. And because of those, the old traditional objects weren't as appropriate for programming these new architectures, these new multi-tier architectures. So we talked to customers about exactly what they were doing, how they were using the technologies, how they're using ADO, how they're using OLEDB, how they're using XML, and tried to design more purposed objects to achieve exactly what they were trying to do in those different scenarios.
Well, you bring up a good point there, talking about the OLEDB and RDO and DAO and JET and stuff like that. It wasn't that long ago when I was looking at the different data access models that Microsoft had, and it was kind of confusing. I mean, even going to our own sites, I mean, it just kind of has this nice a la carte menu of all these different things you can possibly do data-wise, but didn't really try to make it easy for the developer or the customer to come at it and look at exactly what they needed to do. So does ADO.NET kind of fix that issue? Is ADO.NET now the final thing people should be using for doing databases as they're migrating off of all the other models, or do we still have to think about RDO and DAO and OLEDB and all that stuff?
So if you're a .NET programmer, if you're writing a .NET application, ADO.NET is the technology you're going to want to use. So from that point of view, it makes the decision much simpler. How you plug data into ADO.NET and get it exposed if you're a data source is either through OLEDB, as we have today, ODBC, another existing technology for accessing relational databases, or by writing your own .NET data provider, which is a completely managed piece of code that exposes your data, allows it to plug into components like the data set within ADO.NET. So it does make it simpler, I think, for the .NET programmer, because there is a consolidated set of objects that are designed to work well together, and again, explicitly purposed to either work with connected data, work with in-memory data, work as XML. And so I think it's a lot more cleanly factored object model than what we've had in the past.
Okay, so not to get off the topic of ADO.NET, but you mentioned OLEDB and ODBC and a .NET data provider.
Mm-hmm.
So is the .NET data provider the data server side of ADO.NET? Is that what that works?
Yes, you could say it that way.
Okay, so if you're a developer and you weren't trying to read in data, but you were trying to be a database,
mm-hmm.
You would use .NET data provider.
.NET data provider would be one option for you to expose your data. There's an important conceptually, the ADO.NET data providers are similar to an OLEDB provider or an ODBC driver, in that they are the piece of code that talks to the database and exposes the data through common objects and interfaces. But there's an important distinction, which is in ODBC, we were trying to design an interface that was a standard relational ANSI SQL interface to data. And in fact, you mentioned a number of different database technologies. I've been working on technologies for accessing data at Microsoft for about 11 years, and so starting with Kyle Geiger working on ODBC, so they're all my fault. But with ODBC, we were really trying to design a standard interface for working specifically with relational data, and that was its target and continues to be its target. So if you're a relational database, ODBC is going to be the best match to the functionality that you have in your data store. With OLEDB, partially due to sort of a programming model platform shift into the COM world of objects, we're designing a more componentized architecture for working with data. And one of the things that we're doing with OLEDB is accessing not just relational data, but other types of data, and accessing them in a very componentized fashion, so that if you were a simple ISAM data store, comma separated file store, or all the way up to a relational database, we define common objects that you could expose to expose the common functionality of your data store. But both ODBC and OLEDB were designed really to be pretty comprehensive interfaces. ODBC was designed to expose all of the functionality defined by the ANSI SQL standard. OLEDB was designed to expose in a very factored manner all the interesting functionality of data stores, and designed to be both extensive enough and extensible enough that regardless of what functionality, behavior, semantics your data store had, you could expose it through those interfaces. That meant that those interfaces could be the native interface for a particular data store that could expose all of what they were trying to do through those interfaces. The ADO.NET data provider model takes a very different approach, and it says rather than try to expose everything at a low level that a data store might do, let's look at specifically traits of how people use data and how they plug data into the .NET framework. And let's just define very explicit, well-defined behavior and semantics for those pieces of interaction with the database. So when you expose a .NET data provider to a data store, you're not exposing all of the functionality, all of the semantics, all of the background and everything else that your data store has. You're exposing in very well-defined way specific objects for working with your data that we found our customers need when they're building military applications, client-server applications, and offline applications.
And since you say there's all managed code, that makes it work really well within the .NET framework to be very stable and robust.
Right. And as I said, there is the ability to plug ADO.NET consumers into both OLEDB and ODBC. So the way we've done that is we've provided a .NET data provider that talks to any OLEDB provider, and we'll have a .NET data provider that talks to any ODBC driver. So if you are a relational data store, and it's important that you comply with the ANSI standard and the ANSI standard call level interface, then you might choose to expose ODBC as an interface to your data. If you are trying to plug into other services within Microsoft Windows, like Microsoft Excel or SQL Server's distributed query processor, you might choose to expose OLEDB, and that allows you to expose, again, all of your functionality, all of your semantics, and a programmer in writing to native COM object or a C++ programmer can get at all that functionality. If you are trying to pipe your data as quickly as possible into the .NET framework, the .NET environment, then you might choose to expose an ADO.NET programmer. And if you just have some other type of data that you're trying to expose in the .NET framework, you might just decide to expose it as XML because ADO.NET has built-in support for XML. And for some data sources, it actually makes sense to expose more than one interface. So for instance, SQL Server will continue to support ODBC because it's a standard. They expose OLEDB because it's their native interface for exposing all of the functionality of the data store and for integrating with other types of data, for integrating with Excel and other Microsoft products. And we've developed a .NET data provider specifically for SQL Server for providing the best performance and functionality for a .NET programmer accessing Microsoft SQL Server.
Okay, so the data providers need to really think about how it is they're trying to interact with the environment around them, and that allows them to choose one or more of those different ways to get across it. But then the benefit, though, is that on the other side of the fence, the client applications, the people that are consuming that data, they can just do ADO.NET and they can access all of them.
Exactly.
Right.
Exactly.
Okay. So why ADO.NET? I mean, why change ADO and become ADO.NET? And what are some of the benefits and drawbacks of that?
So one of the things we've done is we talked to a lot of customers and looked at sort of some of the architectural trends that are happening out in the field in terms of doing data access. And what we found is that, well, one thing, people are building distributed applications, multi-tiered applications, applications where they need to remote data across the internet, perhaps across a firewall, and where they want to do XML serialization. With ADO, those weren't the design goals when ADO was first, formulated many years ago, and these are the design goals with ADO.NET. So what we've done is we've built in XML serialization into the ADO object model. So it's just simple method calls to take data out of a database, say, and then remote it across the wire as an XML message that can then be consumed by other ADO.NET applications or any application that speaks XML, regardless of what platform it's running on. So, again, we looked around. Everyone is kind of doing this sort of thing, kind of in a manual way, right? They were rolling their own XML serialization, and they were kind of devising hacks and manual solutions to work with, in a distributed environment. ADO.net kind of makes all that go away. It's built into the foundation, so you don't have to. Everyone doesn't have to roll their own serialization
So
scheme.
you can both read in XML and then treat that as an ADO.net set of information, or you can
Exactly.
actually take an existing ADO-based database or data store and push that out as XML.
Yeah, exactly.
Okay. Because with the .NET services and so forth, they use XML and SOAP as their transport layers, and so this would make it a lot easier then for a lot of people to take and actually bundle that data stores together and then pump the data out to other sites and so forth.
Right.
Yeah.
In fact, one of the major objects within ADO.NET is called the data set. And the data set is basically an in-memory representation of data, and it's a relational representation. It contains multiple tables, and you can define relationships for navigating between the tables. You can define constraints on the tables, non-null, primary key, foreign key constraints. And so it's a very rich way to interact with the data. But that data set itself is, I describe it as a scratch pad of data. It's not specific to any particular data source. So you can take data from SQL Server and put it into the data set. You can take data from Oracle, put it in the data set. You can take XML data. You can take data that's generated on the fly by the application in response to user input and put that all into the same data set. And by defining relationships, you can navigate between these sets of data in very powerful ways. So the data set itself provides a great canvas for working with the data. But in addition to that, as Sean was saying, it is a great way to serialize data or cache data. So web services know what a data set is. So if you have a web service, you can have a method that has an argument that is a Boolean or a string or an integer or a data set. And if you call that web method from another .NET client, your data set gets persisted on as XML on the wire and rematerialized as a data set, but you don't have to know that. To you, you're just passing a data set back and forth across these web methods. The fact that the native persistence format of the data set is XML means that if a non.NET client calls the same web service, what they get back is a very standard XML format where it's got the XSD inline at the front, which describes the schema of the data set, and to them the schema of the XML represented, and then a very standard XML format that they can use to interpret the data. And again, they can pass back XML and an XSD schema describing that XML to a web service, and the web service, if it's typed as a data set argument, can view that as a data set, never has to know that the .NET client calling the web service was looking at it as XML rather than as a data set.
So how does the data set object compare to the record set object?
So one of the key changes is that, or one of the key factorings we've done is we've separated the object that you work with the data, that's the data set, from the data access objects and logic. And there's a whole bunch of benefits that have come out of that. One of them is that the data set basically has no affinity to any particular back end, right? So it's completely agnostic with respect to where the data came from. You're not going to find a connection string on the data set. You're not going to find any place to execute SQL. It's just it's a purely back-end agnostic cache for the data.
You get a common type system that uses the common language runtime types.
And then the other cool thing about that is that you can bring in data from multiple heterogeneous data sources and have a single coherent programming model. You can define relationships, as Mike said, between these different data. You can then serialize all of this stuff in a single XML message. So by kind of separating out access from the in-memory cache where you work with the data, you get a lot more integration with different backends and with XML.
So it's kind of playing a little of a middleman. Kind of, he's doing a lot of the data storage and manipulation on your behalf, and you interact with him, and he knows how to get that information from other data sources. Is that it? Or am I getting that kind of?
So then we have the second kind of key object, I guess you could say, is the data adapters. And the data adapters, their whole goal in life is to move data back and forth between whatever back end you're talking about and the data set. So given that we've offloaded all of that functionality on the adapter, that's what allows the data set to be sort of pure and have no affinity to any particular back end.
Mm-hmm. Okay. Now, how does the record set play into all this, though?
So that's an interesting question, because that's basically the first question that we've seen developers coming to the .NET platform, and in particular using ADO.NET, is they have this record set that they're used to using from DAO, that survived through DAO and RDO and ADO, and it's the way that they're used to working with data. So the first thing they do is they open up the framework and they look to system.data and they look for a record set, and they find it's not there. And that was actually a very explicit design of ADO.NET, which was to take the functionality that was a record set and split it into more discretely factored objects. So today in ADO, if you have a record set, you don't really know what functionality you have. You don't know. A record set might be a forward-only record set, it might be a scrollable record set, may or may not be updatable, it may or may not be in memory, it may or may not be holding resources on a back-end database as you scroll through the data. So it's not enough to know that you have a record set. You have to know what type of record set it is. And even then, it's not always clear what resources or what semantics you're going to have when you're working with the data. So for instance, a scrollable record set might be implemented using a component called the client cursor engine, which brings it all into memory and you're scrolling through data in memory. Or it might be implemented as what we call a scrollable server cursor, where it's actually holding resources on the database as you scroll back and forth through the data. So what we did in designing ADO.NET is, again, we looked towards those common scenarios that our customers were using, that we saw developers using when they were building applications. And we defined discrete objects which were optimized towards specific purposes that we saw within those usages. So as Sean was saying, we have the .NET data providers, including the data adapter, which links the database with the data set. The .NET data provider also has an object model very similar to ADO in that it has a connection object and it has a command object, and it has something called a data reader object. And the data reader object is conceptually similar to the forward-only read-only record set that we have in ADO, in that it is the fastest possible way to stream data out of the database. But rather than expose that through a generic object, we designed a specially purposed, optimized object for doing that exposes the data as a stream, that allows you to access it through strongly typed accessors so that you get the best performance when you're reading that data. You're not going through variant data types, which cause conversion overhead and so forth. So part of what was in a record set is serviced by these data readers. Another common use of the record set is to bind to data, for the user to interact with data. And we find that there are really no good scenarios where, as a user is scrolling through data and interacting with data, you want to hold resources on the database. You'll never have a scalable solution if there's any user interaction at all holding locks or holding resources on the database. So the data set provides a nice disconnected model for working with the data. And again, by designing the data set as this disconnected in-memory model, we're able to optimize it and enhance it for a lot of things that users do in interacting with the data. So whereas the record set is basically a single table representation of the data set can have multiple different tables and relations between them. Where the data all comes from one source, the data set can combine data from multiple different sources. Where the data set can sort of persist and load its data as XML in its own proprietary format, the data set is much more generic in how it can load and save XML. So we were able to, again, break the functionality that was the record set into the data reader for streamed access, the data set for in-memory manipulations, and the data adapter for interacting between those. And by doing so, one of the things that our developers find once they get over this, where's my record set question, is that they have a great deal more control over how resources are being used, how they can customize the update behavior, the synchronization behavior, and so forth, because we've exposed explicitly defined factored objects that they can wire together in their own way, rather than have these generic objects whose implementation and behaviors and functionality are sort of unknown to the consuming programmer.
So instead, it's based upon how the connection was set up to the back end, irregardless of what the code's looking like within the ADO program itself.
Well, it's a lot more explicit in ADO.NET in that when you make a connection, you have a connection object, and you explicitly open that connection and use it and close it when you're done. So if you are getting data into a data set to bind to controls, you'll explicitly call a method that populates the data set. You know, once you've populated the data in the data set, you have no more need to hold those resources open, and you can close the connection. So when the user's interacting with the data and making updates, and then if they want to update the data, you know that you explicitly go back to the connected data adapter object and say update. So rather than have a sometimes open, sometimes not open connection that you may need to persist as you're scrolling through the data, it's very, very explicit when you need connections and when you don't.
Well, it sounds then that with all these changes from record sets to the data sets and connectors and stuff like that, the code can look quite a bit different between an ADO program and an ADO.NET program. Does that bring up any problems for developers who have some legacy ADO code they're needing to migrate to ADO.NET?
Well, the existing code is going to continue to work. It's going to continue to work against the existing ADO type libraries. So if you have VB6 code, that's going to continue to work. But if you just use that, you're going to be missing out quite a bit on a lot of what we've built into ADO.NET. So we expect most developers, as they're going to this .NET platform, in order to take advantage of the .NET platform, are going to rewrite a great deal of their applications. And in doing so, we wanted to introduce a programming model that leveraged a lot of what was familiar with ADO, but really defined a better model for working with data in today's multi-tier, distributed, XML-aware community. The other thing that, as I said, we did try to leverage people's existing knowledge of ADO where it made sense. So I have a code example I often give when I'm doing demonstrations and presentations that is sort of the quintessential hello world example for database programmers, which opens a connection, opens and executes a command, brings back the results, loops through the results, writing those out to the console, and then closes the connection in command. And the code for doing that in ADO.NET looks very, very similar to the code for doing that in ADO. In fact, I took a code example I'd used several years ago at Tech Ed, where I was presenting ADO and part of Universal Data Access, and used that same code example and just changed my objects a little bit and used semicolons since it was a VB and now is a C# program. And for the most part, that same code worked. But then I took the code example one step further and I said, well, the .NET framework gives me things like constructor arguments and overloading. So rather than having to create objects and then set all the properties and use them, I can pass those into the constructor and just make it a little cleaner, a little neater code. Rather than have things, individually created and then hooked together, I actually have methods that I can use to create a command from a connection and a data reader from a command. And so I found that I could rewrite the code basically just like I would as ADO, but I could also clean it up a lot by leveraging some of the .NET framework stuff built into ADO.NET.
It's more like turning ADO into a full object-oriented programming language to a certain extent with constructors and destructors and stuff like that. I mean, I've been noticing that database programming, per se, back in the days when I first started programming, there were your database programmers and your non-database programmers, and at least the circles I hung around with, it seemed like the non-database programmers were far more prolific than the database programmers. Whereas now, slowly over time, I'm noticing that you almost can't write a program unless you're doing something with a database someplace. So I can understand how having a rich .NET object-oriented programming language for databases can help an awful lot.
And that's particularly true with the data set in that, as you say, traditionally there was parts of your code that looked like your language. So where you had sets of data, you had arrays or collections or other constructs within the language. And then there was a part of your code that worked with data, and it had a cursor model or a record set. And how you worked with that data was positional. You had to move to the data in order to read the values. It looked very different than how you worked with data in other parts of the language. So one of the things that the data set brings us with ADO.NET is a tighter integration between the language constructs. So by having a common set of language constructs within the .NET framework, like collections and arrays, the data set exposes the data using those common constructs. So when you're working with data in the data set, the data is exposed as a collection of tables. And each of those tables, the data is exposed as a collection of data rows. And so you can use common collection semantics for indexing into those, for accessing them, for adding and removing values, and so forth. So it helps integrate the code much tighter into your language than traditionally, as you've got these separate models of programming your application and programming your data.
Yeah, and we've leveraged the object-orientedness in a couple of interesting ways as well. We have this notion, or something we call type data sets. Type data sets are data sets, they're classes that we generate at design time. They inherit from the system.data.dataset, your generic data set, but then we can add extra properties on those type data sets to make coding with them easy. So basically, you feed us the schema of that data set, all the information about what tables and columns and relationships, et cetera, that you want to program against. We'll generate a class from you that has properties mapping directly to those tables and columns. And so what that means is that when you're programming, say with the generic data set, you have to index generic collections. So it's like dataset.tables, specify the table name, .column, specify the column name. With a type data set, you can just say something like dataset.customers. And boom, you index directly into the customers table. And then from the customers table, you can say .contact name and program directly against that field. So that works very nicely with IntelliSense in VB and C#. Gives you a nice drop-down list of all the schema basically in that class.
So using a true namespace model to get the stuff.
Exactly. Yeah. And then the type data sets, given that it inherits from the generic data set, you can pass it to methods that expect the generic data set and use it as that way. And then, in places in your code where it's appropriate to do so, you can leverage the built-in schema to get cleaner code. You get compile time type checking. So if you set an integer column, say, to a string variable, the compiler will catch it as opposed to getting a runtime error.
So the strongly typed data set is a good example of probably one of the top 3 tenets of ADO.NET. The first being the explicit objects that we already talked about, the second being XML, which we've touched upon. The third being the idea that where developers know something about the data that they're accessing at design time, they should be able to use that knowledge. That is, when we went out in the field and we talked to .com companies when they were still around, as well as financials and so forth, we found that in the vast majority of the cases, the application knew the data source that they're connecting to, the command that was being executed, and the shape of the results that were being returned. And really from the days of ODBC, we had come up with an object model that was designed around a very ad hoc model where you could execute command strings you didn't know against databases you didn't know, describe results that you didn't know, and interpret those and bind to those. And that was very revolutionary at the time, this idea that a shrink-wrapped application could connect to, execute queries, and bring back results that it didn't know at design time. And so we wanted to preserve that in ADO.NET. We do support that in ADO.NET. But at the same time, ADO.NET has more facilities for the common case where the developer knows the command being executed in the shape of results. So one example is a strongly typed data set, this idea that when you know you're getting back a customer object that has certain fields, you can use that as an object. You don't have to have this runtime ad hoc introspection to find out what the object is and what the fields of that object look like and what their types are. Another example I mentioned before is the data reader. The data reader is your stream of results from the database. Gives you the ability, when you know the data types, to retrieve them in their native data types rather than through a generic object or variant type construct. Another area is when working with XML. If you tell the data set the schema of the XML that you're expecting to have, or the relational schema, the sets of tables, when you read the XML in, we'll map it to that schema, as opposed to having to sort of build that schema at design time. And then the final area is one that we've touched on a little bit as well, which is how you populate data from the database into the data set and propagate changes back to the database. And in the ADO model, using the client cursor engine, when we populated data into the record set, allowed the user to edit the data in the record set, the way that we propagated those changes back was under the covers, we generated insert, update, and deletes for each of the changed rows within the record set. And the user had no control over those. They couldn't control how those statements were generated or what values were used in the where clause and so forth. What that meant was that they weren't allowed to use stored procedures for doing the updating, which was a common scenario. Typically, applications don't add new clients to their database by inserting a new row into the client table. Typically, they call an add client stored procedure. But this update mechanism through this client cursor engine in the record set didn't give them a way to plug that in. Well, with ADO.NET architectures, as we've described, it's much more factored in that the data set is where all the changes occur, and then the data adapter is how those changes are propagated back to the database. And the data adapter exposes explicit commands for executing those insert, update, and delete. The developer can use something called a command builder to automatically derive those at runtime, like they do in ADO. But in a typical scenario where they know those at design time, they can explicitly give the insert, update, and delete commands to be used. Those can be stored procedures, they can be other types of commands, they can be whatever the user wants. And then we don't have to do, number one, we don't have to do the expensive operation of trying to derive that information at runtime. And number two, the developer has a lot more control over exactly the semantics of those inserts, updates, and deletes when they're propagating them back to the back end.
So all this just basically gives the programmer more control over making the application behave the way he really wants it to behave.
Right, both more control as well as better performance in many cases.
Mm-hmm. And plus, being in the .NET managed code model, you also get a very more robust and stable performance out of this at the same time. So it seems like it adopts all the tenets that we're trying to focus on with .NET, is making programs run better, scale better, and don't crash at all and stuff like that.
Right. Exactly.
Yeah. Now you mentioned that we hadn't really covered on the XML side very much. Was there more aspects of the XML issues with ADO.NET you wanted to touch upon?
Well, we've touched a bit on the XML aspects just in terms of being able to load and save XML from the data set, but the XML integration goes a lot deeper than that. When we were designing ADO.NET, we understood that XML was becoming increasingly prominent in the industry, and when we talked to customers, we saw that there was a real excitement around XML, and most of them were starting to use XML. They didn't know why it was exciting or why they were using it, but they knew it was going to be important. And as they started to use it, they started to find out why it was so exciting, why it was interesting. There's great facilities for interacting with other components that in a loosely coupled manner. It's a great self-describing format for the internet. There's also some interesting tools and components built over XML for doing hierarchical queries using the XPath facilities, for doing transformations using XSL transforms. And there is an increasingly strong divide between XML programmers and relational programmers. So that with ADO, you had to sort of decide, am I a relational programmer, am I going to use the record set and ADO objects, or am I an XML programmer, and I'm going to use the MS XML, use the DOM model for viewing things as XML. So when we understood this, we wanted to be able to build a model that took both XML and relational into account. And our initial efforts at that was to sort of extend the record set model in a manner that could navigate more hierarchical structures, more tree-based structures. And that was our way to work with both XML and relational data. And we went and we talked to developers, and the XML developers said, well, I see how you're representing my data, but it doesn't feel like XML to me anymore. I'm an XML programmer. I think about things in trees and nodes, and this doesn't feel right to me. And we talked to the database programmers and found just the opposite thing. They said, okay, I understand how you've taken what I knew and extended it to represent this other type of interesting data, but that's not how I typically navigate data. That's not how I navigate relations. So we went back to the drawing board and said, we need to integrate XML and relational data into this model, but when the developer is working with XML, it needs to look and feel like XML. They need to be able to use XML tools like XSLT and XPath over it, which they couldn't in this sort of combined extended relational model. And similarly, when the relational programmer is looking at the data as relational data, it needs to look and feel like relational data. It needs to look like tables, and they navigate those through relations, not by going to child nodes and so forth. So what we came up with was not just building a lot of XML knowledge and functionality and features into the data set, but we have something called an XML data document, which is a W3C DOM model. So it gives the standard XML view of data. Over that is built the XSLT for transforms, the XPath for queries, and you can associate an in-memory instance of the DOM with an in-memory instance of the data set such that you can have a simultaneous XML and relational view of the data. So you can walk through the data in the DOM using your standard select single node or navigating first child, next child, first sibling, next sibling in the XML world, and you can look at that same data relationally. And when you make changes in one, it's automatically reflected in the other. In fact, you can do your XPath queries over the XML representation, and based on the results, you can get the appropriate rows within the data set, make changes to that, and then save it out, do a transform in the XML view, and save that out as HTML to ship off to the clients or whatever else you want to do. So there's a very, very tight dynamic relationship between those two views, the XML and the relational views of data, such that number one, you don't have to decide up front, is this an XML project and application, or is it a relational project or application? And number two, once you've made that decision and you started programming as XML or you started programming as relational, you're not painted into a corner. So if you want to bind your data to controls and grid controls and have the user interact with the data through standard forms and controls, and yet you want to be able to do XSL transforms or XPath queries to get results, you can do that very dynamically. You can build your application from relational into more XML, or from XML into more of a relational model.
That sounds kind of exciting. I mean, it's like almost like, you know, the right tool for the right job, but it's not picking the tool up front, but you can actually have a tool belt you're wearing. You just kind of pick up your hammer or your saw or whatever in the midstream.
Absolutely.
Yeah. Well, that's pretty exciting. Are there any final key points you think you want to get across to the audience about the importance of ADO.NET and what are some of the key aspects of the architecture they might need to know?
One thing that might be worth mentioning is tool support for ADO.NET. So we've talked a lot about kind of the power and control that ADO.NET gives you kind of relative to ADO. We've also got some great tools in Visual Studio.NET that are designed for ease of use and productivity, and to kind of do a lot of the work, the underlying kind of plumbing work for you, so you don't have to worry about that stuff. And one thing with the tools, in the past, we've done some great tools. We do usability testing, and we can bring people who don't know a whole lot about database programming or data programming, and within a couple of hours they would easily get a simple two-tier data application up and running. But often what we've done is we've kind of made you make a choice or a trade-off up front. Do you want the ease of use? Okay, then you go in this way. If you want power, well, then you're going to go this way. And what we've tried to do now is not force you into that trade-off. So the tools really just there's basically one path. It's ADO.NET. The tools do a lot of work to make you productive in that way. But if you decide later on that you need to kind of open up the hood and get down to the underlying mechanics of how your application is running, and you need that lower level of control, the tools don't block you. They're not a black box. So you can kind of drop down to the lower level layers and take as much control as you want later on down the life of your application. We have some great stuff for configuring drag and drop configuration of data adapters. We've got an interesting schema designer for designing type data sets and leveraging that type programming model, programming as your data's objects basically. That's a good way for new developers or people who are new to ADO.NET to kind of get their feet wet.
And all this is built into VS.NET?
Yes.
Mm-hmm. Now, does that also mean that since it's being built into VS.NET, that all the languages that use VS.NET can access ADO.NEt?
Exactly, yeah.
Like
so
Perl,
VB,
RPG, COBOL, VB, C#, C++?
Right, yeah. So that, yeah, it's nothing about these tools makes any assumption about the underlying language, really. So yeah, other languages can plug in. VB and C# were the languages we're shipping, and both of them have essentially the same set of tools, the same user experience for working with data.
But then any language that's based on the CLR can take and access ADO.NET just by the Common Language Runtime.
Yes, exactly.
Okay. Well, thanks. I appreciate the time you spent with us. I hope you cleared up some issues our audience might have about ADO.NET and how it can solve some of their data problems. Thanks, Michael and Sean. So that covers some of the architectural aspects of ADO.NET and what it means to design an application and how to utilize some of the capabilities and power that ADO.NET provides. A little bit later in the show, we're going to take and talk with someone about how to program an application using ADO.NET and what that looks like. So stay tuned.
In these interviews, we've talked a lot with people who do work, start over. So you say your group plays a lot of games, I'm sure, while they're doing the research, of course. What would you say, other than, this is not working out. Also on October 31st, Microsoft released, Microsoft DirectX. I didn't like that. For more information, check out the show transcript for the URL. Sorry, I forgot there was a part under that because there was a space. Sorry. Jesus. Check the shows.
I'm going to have you do it right from the turn there. Darn close.
Hey, thanks for joining me today. It's been great.
Thanks for having me, Erica. It's been a pleasure.
/Windows 2000 /guide /platform
Whatever!
Really? I thought it was, no, it's a download, isn't it? It's a hard one. It's a hard one. So what other jobs have you had at Microsoft? Wait, you answered that basically. Never mind. I think I'm out of questions.
Welcome back. Now we're going to take and focus on ADO.NET from the programmer's perspective. And to help us understand some of the aspect of what it means to program an ADO.NET application, I have David Hawk here from Solutions IQ. Welcome, David.
Welcome. Thank you.
Glad you could join us.
Yeah.
Now, you've been programming with ADO.NET for a while now?
Yeah, for just over a year, primarily on internal projects for Microsoft. Solutions IQ, we're a solution provider, so we come in and work on different companies. Microsoft just one of the customers that we have. So.
And prior to using ADO.NET, you were using ADO,
Yep.
or
Right.
what other database models were you using?
Well, my background, I come from various degrees. My primary focus is Microsoft technology, so yes, I was using ADO, I've used RDO, I've used DAO for, the access type, client server, applications we've developed. ADO, though, for primarily the last 4 or 5 years, doing, connections into Oracle databases or SQL Server access, that type of stuff.
Yeah, because ADO has been kind of the primary client-side connection model that Microsoft's been providing.
Yep.
You've also, I suppose, used like OLADB and ODBC and JET and all those other sort of stuff. How would you compare ADO, not ADO.NET, but just ADO by itself, to the other ways of getting to data from the client side?
Well, one of the things that I found with ADO is in the being able to or from a programmatic point of view, being able to manipulate data and access that data quickly was a strong asset and a reason why we used ADO, having that object model predefined for us, being able to access that data, knowing that we were going to be calling some type of provider was nice. If I was looking to streamline code or get best performance, best practices, then typically I would be looking at some type of OLADB provider or even a natural provider for that particular access. So it really depended on what type of enterprise application I was developing at that time and what the needs of the client was to determine that. But done a little bit of everything. So.
And then when you switched over to using ADO.NET, I'm assuming you use ADO.NET most times now.
Yes.
What were some of your early experiences and thoughts about it?
Yeah, well, one of the first things you notice when you go into ADO.NET is there's no longer a record set object. It's one of the first things that, I'm sure all the developers who went in and looked at it said, whoa, wait a second here, this is ADO, where's my record set object? That's what I'm familiar with dealing with. And then the other thing you notice immediately is, whoa, I have all these new objects that I have to get a grasp on. Even when dealing with the closest synonym to a record set object would be the data set object. Well, now I have to deal with not only the data set object in itself, but that can hold multiple what before I would call record sets. So I have to deal with these individually in their state, from the data set view. So that was the two first things that you immediately embrace into. Then the second thing you embrace into is you have to realize, well, okay, now I have 3 levels of providers to me. I can use my, ODBC, I can use OLADB, or I can use a native provider that, is going to come for that particular database that I want to gain access to. And so you have to learn those type of constructs to deal with those different providers. So,
how big of a hurdle was it to learn all those new aspects of ADO.NET?
I would say, after the initial shock, after playing with it a little bit and seeing how the data sets actually functioned, it was I would say probably a medium level, hurdle to jump over. But, once you sit down and look at what they were actually trying to provide for us, which is a cleaner object model for actually dealing with data, regardless of who my provider is. Then it sort of snapped in, the light sort of flashed in the back of my mind, said, oh, now it makes sense as to why I have to go through these, what initially I took on was extra steps to access my data. Well, in reality, it's actually a cleaner mechanism for me to access that data. It alleviates the fact that I don't have to know where my data is coming from. All I have to know is that I have it into a data set object, and I can manipulate that clear and free of any penalties until I want to return it back to its particular provider.
So what steps did you take originally to learn more about ADO.NET and help you over the hump? Were there books or forums?
Well, one of the things that, there's one of the things we have access to is some great forums and news groups. Microsoft has done an exceptional job of promoting a lot of documentation early on to help in that understanding, and so that was a great asset. The meat of learning something to me is by doing. So what I did is I started constructing simple applications, like your basic hello world applications, but using the ADO.NET mechanisms to, access and manipulate data. And that was a start. And then that gave me enough power to start asking questions. So then I turned to, Microsoft support, and then also the peers and news groups that they have set up out there to, fire these questions off and get responses for to, help, deal with the conversion over.
And hopefully you're going to be able to provide some assistance to some of these people out there in the audience that are trying to learn ADO.NET today.
Exactly. So basically, what I did is I constructed a demo application for the particular show. The primary principle of this application was to show how to get data, manipulate that data, and then put it back into the provider. The provider I chose was SQL Server, and I'm actually using the native provider for SQL Server to deal with that. I could have used OLADB. You'll find actually when the sample code goes up, if you just do a find and replace of anywhere you see SQL with OLADB, it will actually work identically to if I had used the native provider. But actually you'll get speed performances for using the native provider.
So the benefit of going to the native was so you get the SQL Server's raw speed to it directly. And so, but you were saying that all you have to do is just replace SQL Server with OLADB. And
in this case, because the OLADB provider for SQL Server is so in touch with the actual native drivers that it actually is a pretty good sample. So to convert over to OLADB using all OLADB calls, you would just have to do a find and replace anywhere you see SQL to OLADB, and it would actually work.
But if you switch over to use something like FoxPro or Oracle,
you'd have to do
Access.
more. Then you would have to be careful because depending on what calls you were doing, like I use a couple different stored procedures in this particular thing, so those would have to be turned into regular either SQL statements executed against FoxPro or something of that nature. So.
Okay, well, let me take a look at what you have here then.
Sure. Basically, for this particular app, I actually constructed a particular database with it also, and I'll just jump into that first so you can see what the schema looks like, just so we can understand and talk about what the actual application is doing internally. So here's the database that I constructed called Contact Management. And basically this database is a fairly simple one as far as databases go. It really consists of 4 different tables. I constructed basically relationships with these particular tables just so you could see what we were really talking about. I constructed basically a calls table, which is actually going to store a particular call that somebody would make. Actually, they can type in the information about that call. The contact table is actually the meat of the work here. It stores all the information based on that particular contact in it. And then I created 2 others, a contact type table, which is just, really shows what type of contacts we were actually dealing with. And then the company table, which actually stores the company-related information about a particular contact that we're dealing with. So I guess
you're not using a Northwind database?
No, I'm not using Northwind database. I actually steered away from that purposely because we really see a lot of samples that are out there today. Everybody uses the Northwind database, and I really wanted to give them, okay, here's a real world database. Somebody just whipped it together. Here's how I'm going to do access to it so that they can see some different examples rather than using the Northwind database. So I'm going to go ahead and just quickly show the application itself run running, and then we'll go ahead and get into the code just so that you can sort of see what's going on with that particular application. Basically, the application I did was a Windows console application, so, but this easily could have been turned into a web application or some other mechanism to do the displaying of the data. I just chose to do a Windows console application in this particular case to show some of the features of data-bound controls and those type of things.
Actually, Windows Forms application, Windows console have been a command line.
Oh, I'm sorry, what am I saying? Yeah. Windows Form application, not console application.
Well, so there's nothing wrong with console.
No,
I love command line episodes.
I do too. So, but here's the Windows Forms application that we're actually dealing with. Basically, it has a main form which I've called Contact Manager. This form basically governs the different forms that you go to. You'll see that I've created several different drop downs that actually show the listing of what's actually, these are being fetched from the database, the different tables that we deal with. So I have the call maintenance, which shows me all the calls that have been done, so that allows me to go in and update or add new calls. I have the content maintenance, which does basically maintenance of a particular contact, so I can add or remove contacts from this. And then I have the company maintenance, which allows me to go in and add or remove companies to.
Pretty interesting company names in there, it looks like.
Some gobbledygook that I've thrown in there just for raw data so that we can go through the sample, so speed up typing time. So basically what this form is from the other side, let's go ahead and bring up the actual code window of that particular form, and we can sort of see what's actually going on underneath the covers from the initial point of view. On this particular, since this is the base form of the particular application, I actually have this set as the main, actually has the main class within it, which I've defined in my particular project, which you'll see here is the main. What it does is it goes ahead and just creates the application environment and runs the main form, which is the Contact Manager form. And then that particular thing opens the constructor, and then we get into the actual data. On the load, I've done actually, and I've extracted a class or a method called web load data, which actually handles the initial point of where we get into database access.
So when the initial form comes up, that's when all the data comes out.
You got it. It starts loading and populates those drop-down boxes. What I've done in this particular sample is I've created several different public level variables, which is I've created one for the database connection, which I've called dbcon, which is the connection string, sorry. And then you'll see that it's very similar to your connection string, in fact, identical to the connection string that you would use today. Again, you have to denote a server. Because I'm actually using, in this case, the native providers for SQL Server, the objects that are required is the server name, the user ID, and then the password, and then the database that I want to connect to. If I was using the OLADB provider, I would, then I would have to put the provider equals SQL OLADB, and then followed by the username in the same construct there.
I see that here that you, on your SQL Server database, you don't have the common password there, but it's not that much different than the common, just spelling password backwards.
Yeah. So one of the things I learned early on is I never leave the blank password for anything. So for my case, I just do it backwards. So throw a curveball at somebody who might want to access my database for whatever reason. So and that's why I did that. So the next thing we worry about in there is the connection object. Because I'm using the actual SQL native provider again, you'll see that it says SQL connection equals con, and then I instantiate my connection object. Whereas if I was using OLADB, it would say OLADB connection equals con, whereas before I would just have a connection object that I actually called. And then I create a public data set, which I'm calling DS, so for data set. And this is actually going to hold, because I'm using the native SQL provider, all the disconnected data that I'm actually going to fetch back. Mm-hmm. So basically I can drop right into the load mechanism now. So in the load mechanism, the first thing I'm going to do is I'm going to define some type of statement, a SQL statement, so that I can make my calls. In this particular case, I'm just doing a simple select caller ID and subject from the calls table ordered by the subject, so that I have a nice list to populate into my drop-down control. You'll notice the next thing I do is, just for cleanliness, is I make sure there's nothing currently in those drop-down boxes. Mm-hmm. And then the first thing I do is I actually go in, and now I'm actually calling the properties of my connection, just like I would do in ADO of the old. So I do connection string.
So far the code I'm seeing isn't anything different than ADO.
No, it's exactly identical to ADO. Yeah. And then I open that I open that connection so that I've established a link to it. Now here's where the first difference is between ADO and ADO.NET, which is I have to deal with that data in some type of format. I'm choosing to use the SQL data adapter, which actually allows me to go in, execute particular commands, and then I can use that to fill a data set with that data. And so what you see me doing here is I actually make a call. I create an SDA, which is just a SQL data adapter, an instance, and I pass a direction string that I have open to talk to my database.
Okay, so what this is doing, this is then taking the open connection and prepping the data extraction, the filter it's going to have on that prior to actually bringing into the data set locally?
You got it.
Okay.
So basically, there's a couple different mechanisms I could have used here to do this, which we could have used a SQL reader and then extracted the data that way. But the SQL data adapter, what it allows me to do is it holds a state of what I've actually pulled back through it. So if I need to go ahead and update or add, remove, or delete, this is my mechanism, which is the SQL data adapter to do that from the data set itself.
Okay.
Okay. So then what I do is I actually go in and I actually fill my database, my data set, DS, with the actual table that I want it called, which in this case is calls, is what I'm going to actually name that particular data. And you see me just doing that repetitively for each one of the drop-down boxes.
Okay, so what's going on here then on this line 251?
Yep.
Is you're saying that you're taking that SQL data adapter, which
Yes.
now has knows the connection
and also
knows
has
the
a result
SQL,
set.
knows all that. It's now taking and saying fill your data set object, and in filling it, build up a table called
a
calls,
data table.
a data
Yes.
table called calls into that one data set.
Yep.
And then you're doing the same thing with creating another data table called contact, another data table called company.
And what you notice first off is that the data set I'm using holds all three of those tables. So whereas in a record set object, I would have had to have created 3 different record sets independently, or done some tricky working with the actual record set object to create these 3 different tables, data tables in there. So that's basically the mechanism in which I use to do that. And then I immediately close my connection just to clean up what's going on for that particular thing.
Okay, and that basically releases in that backend database.
You got it.
So
now
you're free
I have
of it.
Yeah, I'm free of it, and I have a disconnected data set, which now holds all my data in it that I can manipulate or deal with, regardless of what's going on with my provider.
Okay, so what if that database connection you're building up, the data that it described based upon your SQL queries, stuff like that, was like 5 megabytes worth of data?
You got it.
Would that mean 5 megabytes would have had to come down the pipe?
You got it. It's gonna, and so you want to be very careful, right? And where you use data sets. I mean, data sets is an inline memory, so that's 5 megs of inline memory that you're going to be using. So there's filtering mechanisms that you can actually use. So one of the things you want to do is make sure in your select statements that you're getting distinct points of data back, or taking that data and chunking it out into separate calls and filling it as you need. So that's one of the first things you'll notice. So then now we're going to get into some of the lower objects that the data set actually exposed to me. The data set itself is combined of data tables. Those data tables are combined of data columns and data rows. And then there's another thing called a data view, which is basically a view of data that allows me, just like you would have a view in a database. So it can be a join of 2 tables, it can be one table, it can be whatever you want in a view state mode. So what I'm doing here is the next line of comments. I'm actually creating a view of the data table of my 0 index table. Now that's the first thing that you're going to have to learn to deal with. If you can describe the data ahead of time before you actually do your fetch and bring it back, then you want to use the index ordinals to actually manipulate that data. The reason I say you want to use it is you get a factor of 6 times faster speed by doing that. I could have just as easily done in this line of code here, I could have changed this, actually done, which would allow me to actually reference by the actual table name that I've assigned to it. But because I want to deal with a little bit of performance, and I know the data ahead of time, and I know what the data set looks like, I can actually go ahead and I can use just the ordinal of that particular data table. So as the data tables are, they're a collection, so you'll have multiple tables sitting there. In my case, I have 3, so it's a 0 index collection, of course. So the first table is called 0, 1, 2, and then that's pulls out. And what I'm doing is I'm actually creating a default view of that particular table, which just says, give me back that table. I'm not doing any types of joins or relations to it. I'm just getting the table back in itself so that I can go ahead and manipulate, do a loop through of that particular table.
And that the zero index for the data table is based upon the order in which you did the
You
request.
actually fed it into the data set, exactly.
Okay.
So that's one of the areas you have to watch out for.
So it could be dangerous.
It could be dangerous, yeah, and that's why I say you want to know what your data set looks like and what's actually been fed into the data set and the order that it's been fed into to be able to use that. So in this case, I'm actually just looping through the actual data set or the data table data view that I just created, sorry. And I'm pulling out a particular item out of that to go ahead and add to my combo box, so it has the drop down. The way I deal with that is the data row view. The data row view again it's like a data row in that you can go ahead and look at a data row, and data row view basically is synonymous, other than a data row view is actually dealing with the data table, is dealing with the data view, whereas a data row deals with the data table. In this particular case, and it actually opens up the same objects that I can actually call. Again, I can use in the data row view, I can use either an ordinal here, or I can actually use the column name that I actually want to access at this particular point. In my case, just for readability, I've actually used the column name so that you knew what I was actually calling back and putting into that particular item. Okay. Now you'll see what I've done next is I call table 1. So the difference between this and this is really that the first time I accessed the zero-based table, next time, and now I'm using the functionality that ADO.NET, the data set provides for me, is that that I can have multiple data points in there. So now I'm accessing that other data table. And again, I can go through and I can pull and populate that particular combo box on that. So then the next set of code is really just to go ahead and I created basically I've overloaded the constructor mechanism of this particular class, and I've given it of each one of my I've overloaded the constructor mechanism of each one of my subforms so that I can either pass it no index ID, which means that it's a new record I'm trying to add, or I can pass it an index ID, which means I want to update that particular record. So what you'll see is on my particular call down buttons, I'm actually doing a fetch back to the data set. And in this case, I'm actually using the select statement of the data set, which actually allows me to pull back a filtered subset of the rows based on a condition. In this particular case, I'm doing a SQLite condition, which it says, give me all the data rows that match what my selected index item was. So if I select David under the drop down of so when I select David W. Hawk there, what it does is I'm passing that into this particular string variable called search, and then I'm passing it in as a parameter to my select statement to get back a distinct set of data rows that have a match for that. So that's one of the neat functions that this particular data set gives us. And I can actually put that into a data row collection here and just dump that into there, which is what I'm doing on this particular line of code. And then basically I'm going through and I'm reading through the data set to determine what the integer value of that particular call was so that I can pass that now to the constructor of the add call form so that I can retrieve data.
Okay, so this ID value, you're doing what on this again?
Basically on my data table, saying give me back a distinct set of rows that have an ID similar to this.
Okay. I then go through and I do a for each loop on this particular thing, saying give me each of the IDs that have a similar thing on that. And I basically pass that ID into the form, saying show me the form based on that ID that I've given you. Okay. And basically I just do a hide on my base form and I open up the new form. So basically I'm staying in that thread or that process to do that. So, and to show you the example of that would be to come in here, select David Hawk, and then do update. And what you'll see is all the information based on David Hawk displayed. And the way I'm doing that in the code is the following. So for this particular thing, we're doing contact. So I'm going to go ahead and view code there.
here.
When you do Control Home, goes
Yeah, just dump it through there. So what you'll see that I've done is I've overloaded the public method add contact. I've overloaded it and I've added an int as the overload, as the argument I want to accept. And basically what I do with that is I set that equal to a global variable called contact int, which is defined up here. This is basically what I'm going to use to actually check against to determine whether I'm dealing with an updated customer or whether I'm dealing with a brand new customer in my code logic below. And then I go ahead and I instantialize the components just like I would anywhere else. And so what happens is on the load event, the first thing I do is I do a similar load data call, which is going to pre-populate all my particular drop-down boxes on that particular, or list boxes on that particular form. And I'll go ahead and bypass that because we already saw what that looks like. And the next thing I do is I go ahead and I now open up a new connection to the database because I'm going to go ahead and get either back some data or I'm going to be adding some new data to this particular form. And I do a quick check to say, okay, is this actually a legitimate, is this a new person or is this the existing person? And again, I go ahead and I set up a string variable that holds the command I want to execute. In this case, I'm executing a stored procedure and I'm passing in a parameter, which is connect or the contact ID. Again, I open up a SQL data adapter. I pass in the command I want it to execute along with the connection it uses. And then again, I'm filling in a particular data set. Okay. After that, I go ahead and do some object cleanup. I'm getting rid of the data adapter. I'm getting rid of the connection. And then I go in and I access the next main function of the data set, which is the data table itself. And I create that, call it my table, and I set it equal to the actual table name now instead of an ordinal called contact. Okay. With that, I then instantiate a data row object based on the first row of my data table that I've created up above, which is I'm using the ordinal 0, which gives me the first row. And then I go ahead and I populate all the different text values with the particular corresponding data set values. So, and then down below, I go ahead and I do a little bit of cleanup work to actually get the exact list box item that I'm looking at also. So that's basically how this form populates up with the data that you've seen. So now we get into the interesting area, being able to update or save this particular data. So basically on the command save, basically I do all my work for how to update or deal with that particular data. Now we're getting from the other part. So the first part of any type of application you're going to develop is get the data, put it into some type of data set, okay? Deal with that data set however I'm going to deal with it, and go ahead and manipulate or change the values, add the values, delete the values out of that particular data set. The next part is how do I get my data set back to that provider, which is now what we're going to be showing. So to deal with that, I'm using a SQL command object, which is again is a native command for this particular thing, which is I'm passing in the ordinal name or the actual name of the stored procedure I want it to call, and also I give it the connection. I then go ahead and I define that command type as a stored procedure. One of the nice things they've given us is on each one of the native providers, they give us what type of command types we can actually use. You can use stored procedure, it could be a table, you can do any number of different things depending on what you want to get back. I then, using that command type, I go ahead and I set up all the parameters, all my stored procedure parameters, which allow me to give it a defined SQL type also at this point. So I'm actually now strongly typing to the SQL type that I want to actually send back to the database. I go ahead and I set that I don't want any row source to come back to me. I then go ahead and I now define each one of the values that I want to give it. So, and you see me calling the actual text values. Now this is an unbounded control, right? So there is no data binding going on to those particular values I'm actually going to do back. And if this app was a real app that I was doing for a real world, I'd be doing some validation checks here, some routines to make sure what I'm getting back actually makes sense for that particular data, right? And then down below, the $1 million thing is I go ahead and I execute this. And I call it execute non-query because I'm not expecting any results back. Now, if I was expecting a result set back, like most applications today, when we go in and add something new, I want to see maybe the ID or the entity column back as a number so that I know it's actually been added. In that particular case, I wouldn't put an execute non-query back. I would actually just put an execute query, and it would give me back a record set that or result set then put. So that's for a particular user that is I'm just updating. The only difference between that and the actual insert command is that I now call an store versus actually doing by using the actual data set itself and calling the method add or the method update
or the method delete, and then that will pass it back. You pass that back up to the
after for that to go ahead and update, which was talked segment of this. So again, I'm using the basic same parameters here to go ahead and do that again. And that's really the meat of what goes on with that particular form. So basically the difference now is if I show you the company form, you'll see now that I'm actually using data-bound controls. So it changes out what actually goes on underneath the covers. So on the company form itself, you'll see that it's very similar to the other form. I actually get some data back. I'm using, again, that overloaded constructor and passing in the ID so that I can get some data back from this and actually display that for the end user. And what I'm doing is I'm binding it to the actual, to each one of these are now a bound control. Let me jump into the actual view of this, what it actually looks like when you're actually in design time. In design time, you'll see slightly something different here. You'll now see down below that I have these particular objects, which are my bound, which set up my binding for this particular form to the data set that I'm using. And in this particular case, I've called the data set DS Company 1. And you'll see that on each one of my properties that I have for the particular things, I actually have binding under the data binding. You'd see that normally I would have that text value set to my whatever column name I wanted for this particular case. So in this particular case, let's say I'm looking at company name, I want that bound to the company name. And then it goes ahead and binds that particular data column now to that particular record that's being, or that particular field that I'm actually using.
So now at design time through the GUI, you're specifying that connection, and that way you're not having to do it in code.
You got it. So it saves the developer some time if they want to do this bound mechanism in code. You can also do it through code, doing a calling this particular thing and doing a binding. Let me see here. So if I wanted to bind it in code, I would do something like calling my particular name of my and then I would go down here to bind context. And then I would pass into that I'd pass in that my context that I actually want it bound to. So I would define what the data set is that I want it bound to and also the column name. So that's basically how you would do it through code versus doing it through the UI. So now back to what we were actually doing with this. Again, I do a load. I basically check to see if I actually have an existing person or if this is a new person. And then I do some SQL statements to actually determine what this is. But you'll see now that I'm actually using the pre-generated SQL data adapter that was given to me by doing this as a bound form versus creating a new one. And then I go ahead and I fill my pre-generated data set that it gave me also. and then I go ahead and I do a loop and go ahead and place the data in there for each one of the items that are called. So really where the change occurs is actually in the save commands, because that's really where we're dealing with the data coming back. And instead of where we dealt with it before using a SQL command, I'm actually dealing with it here by using the row begin edit and the row end edit. Okay, what this tells me, what this tells the data set is that I've now changed the values in that particular row and identifies that row as a changed item. So what that does for me is under the covers, it allows the data set to already know what has been changed, so that when I make a call to go ahead and update to or delete or insert to the actual provider, the SQL data provider, it's already denoted what's been changed. It's kept that in its memory so that it knows what's new, what's been modified, and what's been deleted, so that it can go ahead and update the provider of that, which would be whatever my provider is at that particular time, in this case SQL Server. And then what you'll see is down below, if I'm creating a new guy, what I'm doing is I'm actually instantiating a new data row in the actual table. So I'm telling it this is a brand new row.
So
go
rather
ahead.
than begin edit, you call
got
new
it.
row instead.
I call new row and say this is a new row. Here are the values for this particular row. Okay. And then the final thing I do is I actually make a call to the SQL data adapter and I say, okay, I'm done with making new or updated calls. Go ahead and update the source with that, and I pass in the SQL data adapter, and I use a simple method called update, pass it the data set that I have that contains all my adds, edits, or deletes, and then call the table I want it to go ahead and apply those changes to, which in this case is company. So that's basically the demo in its nutshell of how to deal with some simple data access mechanisms from ADO.NET and versus what would have been done before in ADO of old.
So what are some of the standard benefits you've found of using ADO.NET over ADO?
The main benefit I've found is being able to deal with multiple tables within the data set itself. Having that ability not only to not worry about where those tables are coming from is a very strong thing from a programmer because it really detaches it. In other words, if I'm doing a distributed application, before the front-end guys, regardless of what, we could develop COM components in the middle tier that handled that data access, but we still had to worry about where that data was coming from and do a lot of code to actually make sure the data that was coming back was in a format appropriate for that particular provider. With the new ADO.NET mechanism, it actually alleviates that a little bit. So I can now worry more about, I don't care what my provider is, I know I'm going to get some data set from them, and I know I can go ahead and manipulate that without worrying about what the provider is that provided me that data set. And the other beauty of it is really it adds a whole nother layer to us in the ability of XML. One of the things my sample really lacks on is dealing with XML, but you could just as easily build those data sets from if I was a database programmer all my life and I don't want to learn XML, but I know that I have to deal with this web application and the only media that those guys can deal with me in is XML, then I can still use all the strengths I have today to manipulate that data and deal with that data as long as it fits the format into the data set. And the XML guys can go ahead and deal with what they like to deal with, which is dealing with the nodes, dealing with child nodes and that type of stuff in that hierarchical data. And that's a beautiful asset to developers. So I don't have to relearn a whole new object structure to deal with their data. I can continue to deal with it the way I like to deal with data. Mm-hmm. So
plus, if they need to have you supply data to an XML format, you can do that as well.
You can do it easily right through the data set.
Okay.
So those are really some of the strong advantages of ADO.NET. Plus, it really has simplified a lot of things that we had to deal with. It simplified it, but also expanded the uses of it because of the way they've structured the new object.
Okay. So in closing, what are some key points you think you can give the audience on where they need to go to if they're wanting more information about how to actually learn how to program with ADO.NET? Besides, of course, watching this show.
Well, the show definitely helps. I think some of the key areas that they can go to is got.net. which is a great site. On that particular site, they have many different news groups and email groups that you can actually go in, start learning about different subject matters. So like if you're coming at ADO.NET from a web programmer's perspective, you're going to have a little bit different take on it than somebody coming at it from, let's say, a Windows form view or even a console application view of dealing with the data. Yet you're still going to be calling the same base object, right? Because it's held in the CLR, which is the beauty of the .NET mechanism.
So, I noticed you're using C#.
You got it. But I could have just easily programmed this in Visual Basic. Would have gotten rid of all the little colons or semicolons at the ends of my lines and done a little bit of changing in the way I declared my variables. But you know, I could have just as easily done this in VB or any other language that is compliant with the .NET or the CLR runtime, right? So that's a great strength and an avenue for which has been provided for Microsoft to really help developers deal with different disparate data points, which is one of the main things you're dealing with, especially in enterprise applications. You have some mainframe group out there that has some old data set or data structure that you're having to deal with in either a web or a Windows application form, and this really allows you to deal with that.
Okay. Well, thanks a lot, David. I appreciate the time you spent with us and the application you wrote for this demo.
Yep.
And thanks for joining us.
Fantastic. Thank you.
Well, hopefully David has provided you some good information that you can use to help you understand ADO.NET better, as well as if you're not currently an ADO.NET programmer, where to go to for more information so you don't quite have the same hump that he had when he was first starting on. Make it as easy as possible for you. So stay tuned for the rest of the show, and thanks for joining us.
You may have noticed in the last episode we updated the music that you hear in between the segments. Well, with me today is Dave Gross. He is the composer of this music and is also an audio engineer at Microsoft Studios.
Exactly.
Dave, welcome.
Hi, I'm thrilled to be here that y'all are talking to me.
That's great.
It's great.
Well, why don't you start out telling us about what this room that we're in is about, what happens in this room?
Sure. This is one of the main audio control rooms. We have 2 identical rooms like this in studios. It's a digital recording console that controls microphone signals and satellite feeds and telephone signals and any signals that come into the building for all of our live shoots or voiceover recordings. It's all controlled through these consoles, and the signal gets routed anywhere else in the building, and the producers over there can hear it.
So this room is used constantly throughout the .NET show?
All the time through the .NET show. All the microphones we're wearing now are going through some channels here on the board and being fed back to the tape deck and into the production room for Bob and everybody to hear it.
Great. So what does it mean to be an audio engineer? What do you do here at Studios?
I push buttons like this, and little things move. My job tends to specialize more in the post-production end of audio, which means that when the .NET show and all these shows are done, it comes to me to make sure that all the levels are right, to put music in, to edit music, to add sound effects, for example, in the blooper video that I just did of you and Robert and everybody.
Oh, really?
Little sound effects in there that are going to be fun. And that comes to me, it's post-production audio work.
Yeah, great. So besides the .NET show, can you talk about some other fun projects you're working on lately or worked on in the past?
For studios, this is a great place to be because we just do so many different things here. A lot of the Xbox promotional videos are coming through here now, and we're getting to do some effects and music and stuff for that. The Windows Me launch was done out of this building, and it was wonderful. It really actually was fascinating from an engineering point of view because we really pushed the limits of the facility, having all 3 stages, both sound rooms, both control rooms, everything, and live, all at the same time.
Right, very challenging.
And field location, people had people next door at the company store, all over. It was wonderful.
Wow, sounds exciting. So is your background in audio engineering, what did you do before Microsoft?
My background is a lot of different things, primarily as a musician and keyboard player. I've been playing piano since I was 5 years old, and grew up in Orlando in Central Florida area, and spent from basically out of high school until my mid-30s as a touring keyboard player. And during that time I developed writing abilities as well and started working more in recording studios. I did a lot of jingle work, a lot of television commercial production work. writing music, and as a composer I had to mix my own music as well and work with other audio engineers. So my audio engineering on top of the composing developed through that course of those 7, 8, 9 years of doing that.
So are there any name bands that you played a background
Yeah.
keyboard for?
Back in my claim to fame, okay, this is my touch with greatness. Back in the summer of '94, I spent 3 months with the Backstreet Boys when they were first getting started.
Really?
I was one of their first keyboard players, just one of those musicians in the back of the boys, and I wasn't like dancing or anything.
So what was that like? What are they like?
It was a blast because back then they were, I mean, they're still kids, but back then they were really, really kids, and they'd been together for 6 or 7 months, and they had just signed their record deal. They were starting to do the mall tour and the high school tour and just getting their name out. And there wasn't any buses, and there was, we all loaded the band gear up and everything.
So what other things do you do outside of work besides compose music, of course?
Well, my wife and I both ride motorcycles, and we're just fanatic about our motorcycles. We take a yearly trip every year. We'll take off for 2 weeks and just ride to California or ride out to the desert or just take motorcycle trips. And we also do a lot of work with rescued animals, rescued dogs, mostly dogs. My wife is on the board of directors of Seattle Purebred Dog Rescue. And we have a soft spot for greyhounds and for pit bulls and terriers and big dogs like that, but especially the greyhounds.
So can you tell about any fun stories you have about projects here at Microsoft? Or here at Studios, I should say.
Projects.
Or any shows you worked on, or...
I've got an embarrassing story. When I first, one of the things that we have to do is we get to put microphones on people.
Right.
And when I was learning how the proper ways to do that sort of thing, I mean, you just don't go up and stick a microphone on somebody. Well, I had been here about 3 or 4 months, and I was assisting out on one of the stages, and a quick session came up where Bill G had to talk to CNN or somebody. And it's one of the things, he'll be here in an hour, let's go, kind of thing. Well, my manager said, okay, you get to put the mic on Bill. Okay. So I was, I'm so impressed with him anyway, and it's so cool to work here. So I put the microphone on him, and I did everything the way I was trained, but apparently I didn't get out of the way quick enough, because all of a sudden in my headset I hear this, step away from Mr. Gates, step away from Mr. Gates. And so I'm kind of backstepping very slowly away, and I was all embarrassed, and, Bill didn't say anything, probably didn't know at all, but I think I may have been a little too close.
Yeah. Well, Dave, thanks for joining me today. It's been great.
My pleasure.
Very informative.
Thanks for having me.
Well, that brings us to the end of another episode of the .NET Show. Hopefully you learned some things about ADO.NET that will assist you in some of your programming efforts.
And stay tuned for the next episode where we'll talk about Windows Forms and deployable applications.
And until then, we'll see you on the web.